Yeah, this is a strange but mostly good experience. It's profoundly different from the usual poster session, but I think we get a lot of people who don't live in Durham who are actually able to come, so that's good.
Mm-hmm.
Have you all been able to see some of the other sessions?
Yeah.
Good. Yeah, if we ever get to go back to normal, I will do my best to have all these posters printed and we can have a real poster session. So, but I don't know what that's going to look like in the coming year. So. Are you all living on campus in the fall or in Durham or staying at home?
I think I'll be staying at home.
I'm also staying at home.
Yeah.
I'm going to be on campus. Mm-hmm.
Yeah. I will be teaching from this basement, so I have a 400 level lecture class, which is usually about 50 people, and I feel like it would be irresponsible to try to claim classroom space just because you'd need like classroom space for 250 to make that work. And there are things like labs and art classes which maybe need classroom space in actuality. So, but we'll see how it is. I think I will have a TA monitoring the chat basically, and hopefully that'll work. Yeah, the city of Durham is quite enjoying the curveball Duke threw them, because they originally thought all Duke students would be on campus, or at least a large number.
Mm-hmm.
Now all of a sudden juniors or seniors can't be, which means a large number of them are going to go live in town.
Oh. Mm-hmm. Mm-hmm.
Which you can see the issue. Yeah. All right, we'll wait 1 minute and then get started.
For the graduate students, you have to be in certain states to keep getting paid. So there's a list of, I think it's less than 10 states.
Oh God.
Yeah.
Not just 50 states of the US, but.
No, there's very specific states for tax reasons.
Oh boy.
Wow.
Mm-hmm. One of my cohort went to her parents in Pennsylvania, and I guess she's not getting paid now.
Wow.
I guess it begs the question of what does it mean to live in a state? But yeah. Okay, so we should get started. It's noon. Welcome everyone who's joining now. I think others are going to trickle in as we go. So this is the end of our morning session for Data Plus Room 2. And we're very happy to have Data Plus Team 8 working with OIT. And they're going to be presenting on tracking Bryan Center congestion with Wi-Fi data. The way this works is they're going to present their poster and or other demo they have, whatever they have. Take about 5 minutes, somewhere between 5 and 10 minutes. And then we're going to throw it open for just casual poster session questions. If you have questions during the presentation, please just put them in the chat. After the presentation, do as you feel, put them in the chat, unmute yourself and ask, and we'll go from there. So please take it away.
All right. So hello, everyone. We're Team 8. Our goal is to track Bryan Center congestion with Wi-Fi data. I am Sam.
I'm Aston.
I'm Angela.
All right. So our objective is to inform decisions to prevent COVID-19 spread as Duke opens in the fall. And Bryan Center, since it's one of the most congested areas at Duke, our goal is also just to analyze the amount of congestion in each of the areas of the Bryan Center in order for us to make more informed decisions and suggestions to prevent the spread of COVID-19. So another goal is to provide the Duke OIT and student-related groups with data visualizations and to suggest social distancing measures using that. So we have analyzed Wi-Fi logs from Bryan Center's wireless network users, and we were provided with 29 Wi-Fi log history CSV files, one for each day in February this year. The files contain the connection times and their corresponding access points, or what were referred to as APs. And also their hashed user IDs. So we can't actually find the user who they actually are. And we also have an incomplete map of AP locations, as well as accounting floor maps and the list of all the access points for us to work with. So in order for us to create our visualization, we first used a Tableau drawing tool to locate the pixel coordinates of each of the known APs using the incomplete map of these AP locations. And then afterwards, we plotted these coordinates on the accounting floor maps to create a more complete AP map. And the real challenge is to get the coordinates of the unmapped APs because we're actually not on campus, so we cannot physically visit the Bryan Center to get their locations. And to get the coordinates of these APs, we have actually created a Markov chain, which calculates the probability that a user moves from one AP to another. And this helps us get an idea of the relative location of APs compared to each other. And afterwards, we have also implemented a coordinate estimation program, which approximates the coordinates of these unmapped APs using a regression model and also using the Markov chain.
All right, so then in order to get the values for our heat map, we first created a program that calculated and kept track of the AP to user count number. So basically, in order to do that program, we first cleaned the data, so got rid of the authentications and duplicates. So we only had unique associations. Then basically what our program did was, so for every row in our Wi-Fi log, it basically updated the AP count accordingly. So if it was a new user, then the user count for that AP would go up by 1. And as that user moved around the building, the user would be reassigned to a new AP, and the new AP count would go up by 1, and the old AP count would go down by 1. And basically, we reported these numbers in a data frame and later a CSV file that was outputted at the very end of the program. Now, one of the issues that we came across, however, was a buildup in exterior APs where users leaving the building did not have a new row to decrease the AP count by, so there'd be a buildup in certain APs. So we used KDE, which is kernel density estimation, to basically solve the buildup problem by finding the amount of users whose had the last AP was a certain AP, and then we would decrease the AP count accordingly in proportion to that. And finally, to create and finish our heat maps in Tableau, we utilized a Voronoi diagram maker, as we can see here on the right-hand side, where basically we would input our access point coordinates as the input data, and it would generate polygon regions for us that would basically be used for our Tableau heat map.
Okay, so what you see in this section are the results that we got from all this process. The picture on the left is the access point map of floor 3. This is in Tableau, so if you move your mouse pointer around it and move over some of these points that are mapped on this image, then you can see the AP names of each of the APs. And what you see on the right is 2 screenshots of the heat map of floor 2 that we created from the February 19th data. So we created an animation with a 5-minute interval. So of course it will be better to see it as a video than as screenshots. So let me exit this screen for a minute and then share our video and play it. So this is basically for the upper level. And you can see some of these areas.
Update the resolution to like 1080 or
sure. Okay, let's wind it back a little. You can see the time increasing in 5-minute intervals over here. And that's the end of the day. And then we move to the intermediate level.
And one thing that's very interesting on the intermediate level is you can really see, so when there are lectures in the Griffith Theater, you can actually like see that shown on the map, which is quite interesting.
And lastly, we have the first floor, which is the floor with the post office. So yeah, that's the animation that we created. Let me go back to our poster. So by looking at this animation, not only were we able to
That's the issue with YouTube.
Oh, I think YouTube is playing, sorry. So from this heat map, we were not only able to observe like how the foot traffic moves in general, but we could also identify some very apparent hotspots like Griffith Theater, as Aston mentioned, or McDonald's, or the narrow strip-like hallway in the lower floor, or the roof 8 AP on the 3rd floor. And these codes were all given to the OIT so that we can make other kinds of animations with different time intervals or for different dates. And also, if we go back to campus, we can confirm the more accurate coordinates of the APs. So through these means, we believe that we can make more valuable observations from the data, from the Wi-Fi data we have through the methodology we use to create these AP maps and heat maps. So that is the end of our presentation, and thank you.
Thank you all. That was really interesting, both on the video and the poster. Folks, go ahead and put questions in the chat and or just unmute yourself.
Sorry, I think YouTube was like
Autoplaying.
Yeah.
I thought it was a really interesting tool. And I was wondering a little bit, you mentioned that you would select some interval and then you could play back that interval, but does it append the data such that you could have a live view in some ways? Or what are the limitations in terms of viewing something live if people wanted to live monitor campus traffic?
So as of now, our data is based, so it's not live. So basically, we're not exactly sure, I guess, depending on how OIT applies this work, I guess a live tracker could be an option. But yeah, I'm not exactly too sure how the logistics of that would work.
Thanks.
Yeah.
So there's a question in the chat. Let's see. Oh, could you share the poster again, said Angela. Yeah, there we go. Great.
Hi, this is Brendan from UCLA. Thanks for the presentation. I'm interested in how you determined who was on which floors of the building. Are the access points set up in such a way that they intentionally do not overlap floors, or is it just by happenstance that that's the case? Because what I'm thinking about is, whether or not we can eventually give recommendations on setting up Wi-Fi access points so that it's easier when there are emergencies for first responders to determine who is on what floors of a building. And right now, I don't think Wi-Fi access points are set up with that in mind generally. So it's very difficult to really tell people exactly where people are.
Interesting. So basically, how we determined the floors was basically using, so first with the proximity to other APs. So we had in our secondary data that was provided to us by OIT, we had an incomplete AP map location map. So like there were some APs on there, but not all of the APs. So about like half of the APs were on this map. And so basically using our Markov chain, we sort of saw the proximity to the APs that were already on the incomplete map. So we inferred from there.
Okay, thanks.
And to translate for our non-Duke friend, OIT is obviously the Office of Information Technology. So, but that's probably clear from context.
But so the question that you answered, sorry, this is Angela from Duke. Thanks again for everything. I want to follow up on that. I think that's an interesting way to solve the problem of where is this AP located in the building. But once you have a tentative or a fairly confident location for that AP, do users get picked up by APs on multiple floors? Especially I'm thinking about like the stairway area. Like, do you ever notice a device that is switching APs across floors in kind of unusual patterns or anything like that?
I don't think we noticed.
Yeah, go on, Sam.
Okay, I don't think we've noticed switching floors in a random or unpredictable pattern. Usually it's first of all, we know which APs are near the staircase. So we know that when a user is moving up or down the stairs, and it's usually from either top to bottom or from first floor to second floor to third floor. It's usually in a pattern. That's what we've noticed.
Excellent.
Yeah,
Thanks.
so sorry, yeah, I'll just make like a little follow-up. So conventionally, a user would connect to an access point that is located on the floor that the user is on. But of course, there are sometimes exceptions where the user is not connecting to the closest AP that the user is around. So, but also we were not able to sort of like actually observe how that works because we were not on campus. So if we actually go to campus and make some additional data plans of like how people actually move around according to time and how the user's device connected to access points, we'll be able to find a better relationship between users' positions and their AP connections.
Sure, yeah.
Did you ever consider the possibility of asking someone who is from IT to like more check where these are rather than having yourselves go in and look at them? Like, what was the so they couldn't tell you where things were, I guess, is the context of this?
Yeah, so one of the issues, so apparently because there's one person on campus who is available to sort of like checking the accurate locations, like finding the actual access points on campus and like telling us where they were. But then, so apparently like the one person was very busy with doing finding the APs in like the LSRC building and like for some other project, so they weren't available for us.
Guess that happens. Yeah.
Yeah, the computational geometry nerd in me is really happy to see these Voronoi diagrams too. Cool. Other questions folks have?
How, you mentioned another building being mapped as well. How transferable is the work that you've done to another geometry or another building, do you think?
Basically, the whole calculating AP count stuff should be transferable. The main thing that would just be needed to change the polygon coordinates to change for like the floor plan of the new building.
Makes sense.
So you probably heard me ask this question in the other groups if you were here, but of all the dizzying array of technical tools you've used here, what was something you had no idea how to do before the project started, and how do you feel about your progress so far on it?
For me, I'd never worked with like the Voronoi diagrams or KDE, so those two things were new for me.
Yeah, for me as well, I haven't really worked with Python extensions like NumPy, like environments like NumPy or like scikit-learn or pandas, and this Data Plus project really taught me how to use them for data analysis.
Yeah, same with Sam. I learned pandas, NumPy, and scikit-learn, all of them while doing this. Like, it was my first time using them, so it was a great experience. I think it was also very helpful to actually actively know how to use Git, because we did use it in ComSci 201, but it was just like a very introductory concept at that point. So I think like pushing, pulling, doing that all like multiple times, and just in general learning how to share code and code like as a group was very a very valuable experience.
Yeah, my general perspective on collaborative coding and Git and version control and unit testing and all that is you learn it when your feet are to the fire. You know, when you have an important project where you could ruin someone else's code if you do it wrong, that's, you learn it then. So, as you've done here. Other questions folks have? Where's OIT take? I mean, maybe it's not a question for you, but from what you know, where's OIT taking this next? Like, are you being asked to sort of hand over code they can integrate? Are you, there's a question about mapping this over to other buildings? Like, what's the next step? Or was this just sort of proof of principle to show the idea made sense?
Yeah, we shared a whole GitLab repository and the Tableau maps. So yeah.
And I think where the heading is, so for us, we had basically done the animation for one day to get sort of like the concept and like just like what the final product should look like. And then basically OIT will reproduce it for the other days in February.
Mary Claire, do you want to just go ahead and talk from the OIT perspective?
Yeah, absolutely. So I'm in OIT, funny you should ask, and I am one of the project leads for this project. So let me just say, fantastic job, folks, you all rock. We actually had these students show off all of their work to student affairs who use a large portion of the building, and they were definitely interested in using it going forward and passing it around to other folks in like facilities that use the building. And so that's definitely one direction we can take it. And I honestly, like, I think that it's going to be helpful for future monitoring of buildings that we're doing, particularly labs, which are currently open, so that we can understand traffic flow patterns and build up of folks in buildings over time. So very excited to have this great work from the students.
Cool.
Hispanic, Latino, or African American or Native Americans, and I'm not comfortable supporting that comment. I would rather.
Any other questions, reflections, comments?
The system has really gone over.
Brendan again. I just wanted to add that in addition to possible application for emergency operations, I think there's also applications for this for sustainability, right? Because in some types of buildings, it's very difficult to get kinds of sensors in place so that you can correctly control in a smart way the energy usage of the HVAC or whatever else in the building. But if all your buildings are Wi-Fi enabled essentially, and you're able to track with some accuracy in real time eventually of what people are doing, then you can start to be a little bit more careful about how you manage the energy usage in the buildings. And certainly, that would work. Even if it wasn't near real time, you could start to come up with smarter ways of handling overnight kind of energy usage of buildings and things than what people currently do. So I think it's exciting work. Thank you very much.
Glad to share it.
I think you may have already answered this question, but did you specify whether between different days, are you able to identify that it's the same user accessing a point? So you could say how many people were in a zone over a period of time? Is that something that it would be capable of?
Not too sure exactly, I guess, when it comes to the data, whether or not the users, so we have the users and they're anonymized. So I'm not exactly sure whether or not they're anonymized in the same username, but basically for the days, we'll be able to have an animation and the whole counts and all that stuff for each day. I'm not too sure how consistently one user is across different animations.
All right, but if you were to have consistent anonymization, you could sort of get a cumulative count in some way as well with what you have. That's really awesome.
And Mary Claire from OIT is commenting that it's consistent across the data set.
Okay.
Cool.
Yeah, so that could be another future path for these animations.
Well, thank you all. Thanks to all 4 groups in this session. So for folks continuing on to the afternoon, we're going to have an hour lunch break, and then Data Plus and CS Plus and Code Plus are going to start again at 1:30. I'll be hosting in Data Plus Room 1. Kirschlag will be back here. And just want to thank all 4 groups, and particularly this last one. This is really a hard and challenging project, and I'm really impressed at how you all built community while working remotely and actually got a lot of stuff done. So thanks everyone for attending, and we'll see you at 1:30 in different rooms.
Thank you.
Thank you.